Okay, find this page in your packet. We are going to practice sketching transformations for these graphs. All of these graphs are the same to start. So we have to state the transformation and then actually show that on our picture. So this plus 2 at the end, that moves the graph up 2. So we're going to take every point and shift it up 2. And I like to take the key points here, and then I'll connect my dots. So I moved everything up 2, and now I can connect in the pattern of the original. Number 2, this 2 at the end moves down 2. So again, I'm going to take these same points and move them all down 2 units and connect the dots. Oops. Now for 3 and 4, when you're changing your x, we have to think in opposites. So minus 2 really means right 2. So this point moves here, this point moves here, this point moves here. And there's our shape. And number 4, plus 2 really means to the left 2. So this point goes to the left 2, this one goes here. So count your units over. Okay, so at the bottom of the page, now this 2 in the front, that's a vertical stretch of 2. In case you're not sure, what I like to do is take some of my points again. So this point is at negative 4, 2. And that multiplies the y value by 2. So, for example, 0, 0 stays 0, 0. This one matches up there. Then I'll take this corner down here and multiply the y-coordinate by 2. And then here the y-coordinate 0 is going to stay at 0. There's our vertical stretch of 2. You don't have to do this work, but if you're not sure you're doing it right, it's a really good idea. Okay, so here's a vertical stretch, well really a vertical shrink of a half. So I'm going to do the same process, and I'm going to take my y-coordinates times a half. So 2 times a half is 1. 0 times a half is still 0 on the y. And then negative 2 times a half is negative 1. I get my points, and it shrunk vertically. A negative in the front is a reflection over the x-axis. So that means anything up here moves down. 0, 0 stays where it is. This moves up. Kind of looks like a fish, some pliers. The negative in here reflects over the y-axis. So this point reflects all the way over to here. And this point reflects to here. 0, 0 stays. This one goes over to the other side. And same thing, this point goes to the other side. And there's our graph. Now 9 and 10 9 is a double transformation. I want you to try this one now. We're going to pause the video so you can do 9. Is right 1 and up 3. So I'm going to go up 3 and right 1 on every point. And connect the dots. Now for 10, I am going to make a chart of values for these coordinates here. Actually, I'm going to do that for every single point. So I'm going to erase those. The reason I'm going to do that, this is the absolute value of the entire function. So to be sure, I like to write down every coordinate. So I'm going to do -4, -2, -1, 0, 1, 2, 3, and 4. And the corresponding y values because now when I go to graph it, I want the absolute value of f of x, which is really the absolute value of y. So I'm going to take all of these coordinates and take the absolute value of the y. So when I go to plot my graph, I'm going to use the x and the y values. So -4, 2, -2, 2. So these stay the same. But now on this side, it becomes 1, 1, 2, 2, 3, 1, and 4, 0. So what you notice is it takes any y value that was negative and makes the y value positive, but the x's stay the same. Your job now for the rest of class is your homework worksheet. It's the next page. It says 1.9c function transformations. You're to do both sides. All of the answers will be on Edline, so you can check your work tonight before class the next day.